Emily, and I'm back with our part 4 of lesson 9.4. Today we're going to be talking about how to convert from vertex form to general form. We also are going to go ahead and take a look at converting from factored form to general form. So again, how do I convert from factored to general, and how do I convert from vertex form to general form? To begin, we're going to review. We're going to review the three forms and what they tell us. The first form I have listed here is the factored form. The factored form is the one that has the two sets of parentheses, and the roots are the key feature of this form. It tells us the x-intercepts, or those roots, that's where it crosses the x-axis. Note that the a value is going to be the vertical stretch or shrink of it, as well as if that is a negative a value, it will tell you that it was reflected over the x-axis. The second form we have listed here is the vertex form. The vertex form is known for telling us what the vertex is. The vertex is always the h comma k value. Remember, the vertex is the maximum or minimum of a graph. It also tells us the axis of symmetry, which is the h value of the vertex, written as the equation x equals h. And again, the a value is the same as what it was in the factored form. It's telling us the stretch or shrink, as well as if it is negative, it is a reflection. The third form of the quadratic function that we work with is the general form. The general form is going to tell us our y-intercept. Recall that our y-intercept is the c value. That's the value at the end, and that's where it crosses the y-axis. And again, we see that that a value is showing whether or not it's been stretched or shrunk, as well as if it's negative, it is a reflection or flip over the x-axis. Let's move into taking a look at how do we convert between the different forms. You'll see that I've added an extra step, and the two steps that are added in here that are different from previous lessons are step 4 and 5. Technically, we only sometimes need to distribute a number, and that's if there's a value in your problem. And then the last one, step 5, this only applies when converting from vertex to general, but sometimes you need to combine like terms one extra time in the process. So just be mindful, it's slightly different, but really we're just following our order of operations and expanding out the problem. Let's go ahead and take a look at our first example. Our first example is going to be converting from factored form to general form. I see that this is in factored form because I have a factor that is not being squared, and I have another factor that is not being squared. So step 1 of this is I've already created our 2x2 box. Next, I'm going to fill in or set up my box by putting x minus 3 across the top and 4x minus 5 along the side. Now that I've set up my outside of my box, I'm going to fill in each square by multiplying the terms on the side. 4x times x is 4x squared. 4x times negative 3 is negative 12x. X times negative 5 is negative 5x, and negative 5 times negative 3 is positive 15. Combining my like terms on the inside, I see that I am left with 4x squared minus 17x plus 15. We've now worked through step 3 of this process, but I'm going to check, do I need to distribute a number out front? And in this case, I do. I had a negative 2 that was out front. So I need to make sure that I don't forget about distributing that in to each term inside of these parentheses. After distributing, I get negative 8x squared plus 34x. Negative 2 times negative 17 is a positive 34. And negative 2 times positive 15 is negative 30. This now has turned into the general form of our quadratic equation. All right, let's move on to example 2. Example 2 is going to demonstrate how do we convert from vertex form to general. I can tell that this is in vertex form because I have this squared term. Now, I encourage you always write this out so you don't make a mistake. So what this looks like expanded or written out would be 3 times x minus 2 times x minus 2 plus 5. Next, we're going to set up our box with our two binomials. So I'm going to place x minus 2 along the top and x minus 2 along the side. Filling in each square by multiplying the terms on the side of it give us x squared minus 2x minus 2x plus 4. Step 3 of our process says combine like terms. Our like terms in this case are negative 2x and negative 2x. In doing this, I get x squared minus 4x plus 4. Now, as I rewrote this, notice that I brought down the 3 that was in front as well as the plus 5 that originally was at the end. Step 4 of the process says, be sure to distribute. Distributing means multiply the 3. Now, sometimes students get confused. The 3 is only multiplied to each term inside of the parentheses. Note, I'm not going to multiply the positive 5 by it. This gives me y equals 3x squared minus 12x plus 12. And don't forget, I still have my plus 5 at the end. This is that extra step I was talking about. When you're in vertex form, you have to go back through and combine like terms one last time to get your final answer. In this case, my final answer becomes 3x squared minus 12x plus 17. Whew, that was a lot of work, but well worth it. I hope this helps in understanding how to expand or convert from the different forms into general.